23 plus 35.5. Sodium, 23. Chloride, 35.5. Sodium chloride, 58.5. So 1 mole of sodium chloride, if I took, the atomic weight is 58.5, if I weighed out 58.5 grams, there are 6 times 10 to the 23rd molecules of salt in this bag. I don't have to count them. I know that to be a fact. Okay, now let's blow you away a little bit more. Let's get working some more. Here's glucose. It's 1 mole. Quail eggs, ostrich eggs. There's still 6 times 10 to the 23rd molecules. Each of these is 1 mole. Why is this one so much bigger? Because glucose is a bigger molecule than is the salt. Let me get a different pen so you can see it. Okay, that's glucose. So all I did in this case, I took the atomic weights times how many there were, 180. So I have 180 grams of glucose in this bag. I have 6 times 10 to the 23rd molecules of glucose in this bag. Randy's mouth's hanging open. You got it?
Oh, I got it.
Okay. I just didn't want one of those. Okay.
It's hard to break through. Yeah.
Oh, okay. I just want to make sure it wasn't confusion. All right. So what is a mole? Oh, you just have to answer rather than clicker. I don't look for the clicker. Oh, I don't have the clickers turned on. Just tell me, what do you think?
E.
It's E. So it's both that number. Oh, that shouldn't be a minus. Sorry, that should be a whole number. And it's calculated by weighing out that atomic or molecular weight in grams. Of course, those two are also moles, but. All right, now we have to look at molarity and molality. I have to keep pushing on so we can understand how the hypothalamus determines whether or not we need to drink. I know I'm kind of eating into the lab, but I can't understand the lab if we don't cover this. So a molar solution is 1 mole of the thing, and then we add enough water to make it a liter. So a 1 molar solution of sodium chloride is 58.5 grams of salt, and then we add enough water to the beaker to get it up to a liter. If we wanted a 1 molar concentration of glucose, then we put 180 grams in the beaker, and then we add enough water to get it up to the liter. We already talked about this. We talked about moles. We talked about hydrogen concentrations. Now we really are talking about the sugar in the tea. So here's the sugar in the water. We could call it a cup, and I added it to up to, a gallon. It's pretty sweet. I actually like half cup in a gallon, but I digress. We're not really sure though how much water there is. I think you would agree that there's less water in the sugar side than there is in the salt side, just because the pile is bigger. All right, the hypothalamus doesn't judge how salty your blood is, how many particles there are in your blood that way. Instead, it does it as a proportion. The number of particles against the number of water molecules. It needs to know how many water molecules there are. And that gives us molal. So we put in 1 mole and we add a liter. We put in 1 mole and we add a liter. However high it makes it. Now we are a liter to a mole. 1 mole and 1 liter is 1 molal. And notice 1 kilogram of water at sea level room temperature, 1 kilogram is 1 liter. That's why 1 cc is the same as 1 milliliter. I know that cc's have fallen out of favor. I used to have to do cc's all the time as a nurse. Now you do milliliters, but they're the same. So now we have the concept of osmolality. Does water want to move? Now we put it all together. Do you remember ionic bonds? What happens to an ionic bond in water? What happens when we put an ionic bond in water? It comes apart. So here we have 1 molal of glucose, which is a covalent bond, 1 molal of sodium chloride. The sodium chloride comes apart. Now we have 2 units. This has twice as many particles, as does the glucose side, which means water wants to move over here. There's less water over here because there's twice as many particles over here as there are on the glucose side. So water wants to move over to the salt side, even though we started out with the same amount. That's why we had to do the ionic bond thing from chapter 2. This moment comes to this moment. Why we had to talk about ionic bonds? Because ionic bonds fall apart. And then as far as the hypothalamus is concerned, there's twice as many particles over here, which means you have half as much water. So water needs to move. This explains IV fluid. The number of particles in your blood is 300 milliosmoles, or 0.3 osmoles. That's what normal is. That's what those IV fluids are. In the absence of a doctor's order, you hang normal saline or you hang D5W. D5W is dextrose, right-handed glucose, 5% in water, is what D5W is. So it's just sugar water. Now, when you get to nursing school, you'll learn, however, that the glucose is immediately moved into the cell, and you just have plain water in the cell, in the IV, really. But it explains why we hang the IV fluids we do.